Meet Lion Forests, the lesser-known brother of Tiger Woods. He too plays golf, but because he's the younger child, he never got as much attention from his parents as his brother Tiger. This makes him quite sad. Lion has had great misfortune not only in golf, but also in math. In fact, he's contemplating dropping out in order to pursue his mini-golf dreams of success at TWU. However, in order to make this a reality, he has to pass math, which he doesn't know how he's going to manage. In fact, he doesn't have a dream anymore after finding out that TWU stood for Tiger Woods University rather than Texas Women's University. Yet another of his brother's achievements to belittle him. One day, Lion stayed after school to talk to his teacher, Mr. Queen, about the troubles he's had in math. Mr. Queen gave him an inspirational talk about how golf and math really aren't that different, and by applying basic math skills to golf, he could get even better at both. The next day, he went to school ready to learn about this newfound wisdom instilled in him by his glorious math teacher. The second problem that Mr. Queen explained was 3 divided by x squared minus 4. So once again, your first step is going to be to factor both the numerator and the denominator. Here, you can't really factor the numerator, but the denominator factors to x plus 2 times x minus 2. So that means that your domain would equal 0 at positive or negative 2, so your domain is x is such that x cannot equal plus minus 2. For the y-intercept, once again, we're just substituting the x for 0. So here, when we look at the original equation and substitute x squared for 0, you have 3 divided by negative 4. So your y-intercept is going to be negative 3/4. Then your horizontal asymptote. Here, the degree of the bottom is greater than the degree of the top. And the rule is that when the degree of the bottom is greater, then your horizontal asymptote is going to be y equals 0, which is what it is in this case. Here we don't have any horizontal asymptote intersections, nor do we have zeros, because there is no x value on the top. And then for symmetry, it's about the y-axis, which we can find after graphing, and your vertical asymptotes are going to be x equals 2 and x equals negative 2, as we found in the domain. So when we graph, the first one that we can is 0, negative 3/4, because that's the only point that we actually have. So when we have that here, we have to find that our graph is going to lean towards these asymptotes and make a parabola type shape. And then, since we only have one, we have to find 2 more. In this case, the best one to look for would be 3 and negative 3 because they don't touch the asymptotes. When you plug 3 into the graph, for the x value, your y value is 3/5. And then when you plug negative 3 in, your y value is also 3/5, which makes a graph that's kind of like this. And by looking at this graph, we can see that there's symmetry about the y. The next problem was x squared plus 3x minus 10 divided by x squared plus 8x plus 15. Once again, your first step is going to be to factor out both the top and the bottom. And when you do, you find this, of which you see x plus 5 on both the top as well as the bottom. So now let's look at the various components. The domain is going to be x is such that x cannot equal negative 3, because when you equate x plus 3 to 0, you find that x equals negative 3. So that means that your vertical asymptote is going to occur at x equals negative 3. Next, your y-intercept. When you plug in 0 for the x's, you're left with negative 10 over 15, which simplifies to negative 2/3. Then your horizontal asymptote. Since both the top and the bottom have the same degree, it's going to be dividing the leading coefficients, of which both is 1. So your horizontal asymptote is going to occur at y equals 1. And there is no intersection between the lines and the horizontal asymptote. For your 0, you're just going to take you're going to take the non-whole point from the top and equate it to 0. So here, in this case, you do x minus 2 equals 0, and then you'd find that your 0 occurs at 2, 0. There is no symmetry in this graph, which we'll find after we've graphed it, and your whole occurs at negative 5, and when you plug negative 5 back into this equation, you'll find negative 5 plus minus 2 is negative 7, and negative 5 plus 3 is negative 2, which gives you negative 5, 7/5 for your whole. And now let's look at the graph. So first, your vertical asymptote occurs at x equals negative 3, and your horizontal asymptote occurs at y equals 1. And when you plug in the points, 0, negative 2/3, and to 0, you get a line that looks kind of like this. And for your wholes, you have one at -5, 7 halves, which is a little above 3. So that's going to occur there. And we need one more point just to make sure that it goes like this. So I plugged -4 into the equation and substituted that for x. And when I did that, I found the point -4, 6, and that's how my graph ended up. The next example that we're going to look at is x squared minus 5x plus 8 divided by x minus 2. So because this has a numerator that has a degree that's 1 greater than the bottom, we're going to have an oblique asymptote again. But before we look at that, let's look at the other various components of the function. So for the domain, when you set the denominator equal to 0, you find x is such that x cannot equal positive 2. So that means that our vertical asymptote is going to occur at x equals 2. Next, let's look at the y-intercept. So when you substitute x for 0 in the equation, you're left with 8 over -2, which simplifies to -4. So that means that our y-intercept is going to occur at 0, -4. Next, let's look at the oblique asymptote, which is found by dividing the top by the bottom. So when we divide synthetically, we find that the oblique asymptote occurs at y equals x minus 3. And this equation does not have any zeros because when you simplify the top, you find that it simplifies to an imaginary number, thus meaning that there are no zeros in this equation. And it also does not cross the oblique asymptote, so there's no oblique intercept. So next, when we plug in this equation, when we graph this equation, we have to graph our vertical asymptote that occurs at x equals 2 and our oblique asymptote, which is y equals x minus 3, which looks kind of like this. And because the only point that we found was 0, -4, I had to find other points that would help us graph the equation. So I plugged in the value +1 for x, and then I found the y value of -4 and 2/3. So that makes this graph looks kind of like this. And then in order to find this part of the equation, I plugged in y equals +3 because that is around this area. And when I did that, I plugged in x equals +3, and then when I did that, I found the y value of +2, which makes the graph look kind of like this.
Lion was amazed at the newfound skills he had acquired from Mr. Queen. However, he still didn't quite understand solving radical equations. Silently, he cried about not being able to pass math. That night, he heard a knock from the door. It was his brother Tiger.
The next problem that we're going to look at is the cube root of 1 minus 2x equals -3. Once again, the first thing that we have to do is isolate the term by itself, which is already done. Next, what we have to do is cube both sides so we can get rid of the cube root. So when you do that, you have 1 minus 2x equals -3 cubed, which is -27. The next thing you do is you subtract 1 from both sides, so you have just the -2x by itself. When you do that, you have -2x equals -28. And then you divide both sides by -2 to isolate the x term by itself, and then you get x equals 14.
After Tiger taught Lion how to do the last chapter of his textbook, Lion passed with flying colors. He then opened his own university, LSU, or Lion Super University, which finally allowed Lion to be better at Tiger than something, and that was education.